We are choosing option 1, which to predict iris flower species. The objective of this task is to predict the species of iris flowers based on the length and width of the sepals and petals. Firstly, we need to mount the Google Drive with Google Colab because the CSV file is in the Google Drive. Then we import all the necessary packages for the project. NumPy will be used for any computational operations. We'll use Matplotlib and Seaborn for data visualization. Pandas help to load data from various sources like local storage, database, Excel file, CSV file, and others. Next, we load the data using pdread_csv, and set the column name as per the iris data information. pd.read_csv reads CSV files. CSV stands for comma separated value. From this description, we can see all the descriptions about the data, like average length and width, minimum value, maximum value, the first quartile, median, and third quartile distribution value, etc. Next, we run df.info, to get the information about the data frame and then check for outliers for categorical data. To visualize the whole dataset, we use the Seaborn pair plot method. It plots the whole dataset's information. From this visualization, we can tell that Iris Cetacea is well separated from the other two flowers. And Iris virginica is the longest flower and Iris Cetacea is the shortest. Now let's plot the average of each feature of each class. Here we separated the features from the target value. np.average calculates the average from an array. Here we used two for loops inside a list. This is known as list comprehension. List comprehension helps to reduce the number of lines of code. The y_data is a 1D array, but we have 4 features for every 3 classes. So we reshaped y_data to a 4x3 shaped array. Then we changed the axis of the reshaped matrix. We used Matplotlib to show the averages in a bar plot. Here we can clearly see the virginica is the longest and Cetacea is the shortest flower. Now, let's delve into the machine learning segment of our presentation. To begin, we randomly selected some machine learning classifiers to scrutinize their performance. Following a thorough comparison of their scores, the classifiers exhibiting the highest accuracy were identified as nearest neighbors, neural network, and QDA, each achieving a perfect score of 1. After thoughtful consideration, we opted to employ the nearest neighbors classifier for this presentation. Following the division and training of our dataset, we proceeded to generate a confusion matrix and a classification report. In the classification report, precision, recall, and F1 score metrics for all classes yielded perfect scores of 1. Moreover, the overall accuracy, macro average, and weighted average metrics also registered flawless scores of 1. Next, some visualizations pertinent to the nearest neighbors classifier. First in line is the confusion matrix, which is a table that is often used to describe the performance of a classification model on a set of test data for which the true values are known, providing a comprehensive view of the classifier's performance. Subsequently, a nearest neighbor plot which represents each data point in a dataset and shows its nearest neighbors based on a defined distance metric. In conclusion, by employing nearest neighbor classifier and meticulously analyzing their performance metrics, we've laid the groundwork for precise iris classification. That is all for this presentation. Thank you.